Okay, so back to Mr. Jeffries, Algebra 2. We have reached the 3-digit mark of subscribers. We have, last check, we have 103. So now all we need is 897 more subscribers to get to that 1,000 mark. Okay. Yeah. So don't forget, if you hadn't done so, hit subscribe, hit the like, hit the bell. Today we're going over adding, subtracting, like rationals and roots. We're also going over solving radical equations. I'm kind of tweaked it from last year. That's why there's a new video. Okay. So treat each radical or root like a variable. You can only combine like terms. Now, for those people that had issues with this past test, not knowing what combining like terms was, okay, kind of important. I might circle that, star it, write you a note that you can write on your orange sheet later instead of just writing examples. You know, you can do notes and examples. All right. So that's the wrong thing I needed. Okay. So this is the 4th root of 10 and the 4th root of 10. This is understood to be 1. All right. This is going to be really hard. Remember, use a calculator if you need it. What is 1 plus 7? And that's it. Yep. That's when we treat each radical or root like a variable. That's it. Okay. On B, we have 2 plus 10. What is 2 plus 10? 12. And then we would still do this crazy 8 to the 1/5 power. Okay. That is a root. We're just going to leave it right there. Okay. It's a root, it's a radical, whatever. Okay. Come on, scroll with me. Scroll. Come on. Where you at? There we go. Now, sometimes we have to simplify root before we can combine them. Okay. Now, this is where we need to use some clues. Okay. So get out your handy dandy notebook and get ready to write these clues down. Okay. Did y'all watch Blue's Clues? Okay. So think about it like this. A lot of times, when I say a lot, it's about 85% or higher. This other root is going to actually help you find this one right here. Okay. This is the cube root of 2. Okay. Now, if we were to take 54 and let's just take 54 and divide by 2. Okay. We actually would get 27. I wonder if we could take the cube root of 27. We can. What is the cube root of 27? 3. Okay. So if we have 3 of something and we take 1 away, how many do we have? 2. Some of y'all are like, wait a minute. Wait a minute. This has to be harder. Not really. Okay. I could make it harder, but I don't want to. Okay. What? Where you lost? This somebody unplug him and plug him back in and see if we can do a hard restart. Where okay, where So what we did, all right, okay, we were using this to help us reduce this. So I just, for funsies, just divided 54 by 2 and got 27. Okay. I wrote it like this because I can actually take the cube root of 27. The cube root of 27 is 3. Now I have like roots that I can actually combine these together. Who just said, like they understood it a while ago. I just explained it again and now you're even more confused. Okay. Okay, you're good. Okay. Yeah, for now. All right. And I know some of y'all are being like, I know I did this when I was learning this. They're like, oh man, he just told us that we have to make sure that our roots are the same to combine them. And then all of a sudden something's wrong. So I'd put not possible. And the great white would say, not correct. Okay. The great white was my math teacher. All right. So, number 19, it says simplify the expression. You may see these directions again. I want y'all to know these directions. That way, when you get to said test next Wednesday, you're not confused by said directions. And two of the four people that had problems with that were not listening. This is awesome. So, these are the same. What is 8 plus 15? 13, fourth root of 2. Okay. This one right here, these are the same. 7 minus 17. Yeah. Negative 10 cube root of 13. All right. Oh, I'm sorry, not cube root, fifth root. I wrote the wrong number in the gutter. All right. 4 plus 7 is 11. 9 to the 1/4 power. Okay. Granted, we could actually write this as 11, 4. I'm not going to make you do that. Okay. All right. Good so far. All right. So let's look at these right here. Now, we're going to use our, it's kind of like, I don't know if y'all have ever seen the meme that says that, you're sitting there watching stuff on the Netflix or streaming service or whatever that says, these are the most unsolvable crimes that's ever happened. I wonder if, and then you're sitting there eating your cheese balls out of the big, like, plastic tub thing in your pajamas going, I think I got it. Okay. Maybe. Okay. So these are not the same. I wonder if I can divide 18 by 2 to get to something that I can deal with. I can. 18 divided by 2 is 9. Okay. So I can actually simplify this as 4 times, like we take the square root of 9 out, which is 3. Okay. What is 4 times 3? Yeah, 12. Yeah, and then this would be negative 3. Oh, shucks. I've just been writing all types of numbers wrong. This is what happens when I get sleep. All right. So Again, kind of one piece at a time. Okay. One piece at a time. And it's not a race. There's no reward for being the first one done. The intense look of confusion is interesting. Yes, this is a documentary. You know, I am a YouTuber, so semi famous. I have over 100 subscribers. I'm kind of a big deal. All right, let's look at this one. All right, I bet. What do you think 63 divided by 7 is? Aha. What is the square root of 9? Okay. What is 12 times 3? All right. So now we've got it where we can put it together. So 8 plus 36 is 44 root 7. See, this is kind of, some of this is sometimes is kind of like a good marinade. You just got to let it sit for a little bit and sometimes massage it in. Massage, massage. All right. Now, contrary to popular belief, I don't know all the roots of everything. Okay. I'm just going to take a gamble right here. Okay. I'm going to divide 405 by 5. I'd get 81. Okay. The fourth root of 81 is 3. Okay. What is 3 plus 2? 1, 2, 3, 5. That's that math magic. If y'all didn't see it, you'll have to watch the video later. Now, huh? Magic math, yeah. Now, I already can hear what some of y'all are thinking, even with my bad ear. We like problems like 19 through 21. We don't like problems like 22 through 24. Okay? Have to show them to you. We're going to tiptoe into it, but I tried to not do them very fast. Try to talk them back through there. Again, if you happen to miss something, you can always go back, or this is this crazy thing, you could actually speak to me. Yes. And problem 22. Okay. That's a good question. The question was, where do we get 4 times 3? I forgot to write the 4 right here. Now, is that more better? Okay. I like it when stuff is more better. Okay. Wouldn't it be funny if there was a language arts teacher or a grammar teacher using these videos about how not to talk? Like, students, don't be like this guy. He says more better. It's not really a thing. I don't know. That sounds like a you problem. All right. So, a little different, but it's doable. All right. Solving radical equations. Okay. I wonder if there's steps to do this. Cricket, cricket. Yes, there are steps to do this. Isolate the variable. Raise both sides to the power of the radical and then solve. Okay, that's the actual steps. So now, when I say isolate the radical, just like if this was the variable, if this was 2 times x, what would we have to do right here to get rid of the 2? Divide. So we now have the square root of x plus 1 equals 2. Okay? Now, what would we do to get rid of this square root? We'd raise it to the second power. So I actually do that to both sides. Now, when we have a root raised to the same power right here, remember, like I said yesterday, it's like a tornado. It comes through and just takes the roof off. Now we just have x plus 1 on one side and 4 on the other. I wonder how we're going to solve. Yeah, subtract 1. Yes, finally somebody said something really quick, made me feel better. Bam! X equals 3. Okay. Why are you shaking your head no? Did I do anything different from the steps? All right. So, hang on. I'm trying to. So, Anna, how would you isolate this variable right here in 2x equals 4? Huh? You divide by 2. You do the opposite. Okay? To get rid of a square root, we have to square it. You have to do the opposite of what's being done. Okay? Teenagers should be all over this like a fat kid on a cupcake because y'all love doing the opposite of what people tell you to do. Just like when I tell people, don't use photo math. I know you're doing it. People are like, no, that man don't know what he's talking about. All right, let's look at number B. Here is our radical. Okay. I've got to get rid of this minus 1 by doing the opposite. What would I do? Add 1. I'm dramatic effect. I am not responsible for how y'all react to me. All right. So now we have the cube root of 2x minus 9 equals 3. All right. Now, I've got to raise both sides to a power to get rid of the cube root. What power do you think I'm going to raise that to? Yes. All right. And 3 to the third power is 27. All right. Now, how would I get rid of the minus 9? Add 9. Thank you. 2x equals 36. Bless you. How would I get rid of the 2 that's being multiplied by x? Divide it. So x equals 18. No, you can't leave in the 1, because if you were to leave in the 1, then you would actually have to cube this whole radical and 1. Yeah. Okay. What I'm trying to say is, if you try to do it with all of it together, is if you had this right here. Yes. No. Yes. That's why if you ever see me writing radicals, I do this little tail right here to let you know that, hey, when I write it out, not when I type it, when I write it out, it's like, hey, that's the end, because I used to get confused on that all the time on problems like this. I would think the 1 is up underneath the house. It's not. Okay. Kind of. Yep. It kind of groups what that radical is. It's kind of like we've been learning Ninja Turtle math this week. Radical. Okay. Yeah, I went there. Now, number 1, this is on the back of your handout or page 2. The radical is already by itself. What would I have to do to get rid of the square root? Square it. Three x minus 2 equals 25. Okay. How would I get rid of the plus or the minus 2? Add 2. 3x equals 27. Divide by 3. Okay. Now, here's the crazy part to all this. This step right here that we're doing by squaring both sides, that's the actual algebra 2 thing right there. After that, all this is algebra 1. Okay. Some people are like, what does that mean? Well, think about it just a little bit. Just a little bit. All right. Number 2, it's already isolated, so I need to square both sides. Square, square. Okay. So I get 6x plus 1 equals 81. I would subtract 1. And then what would we do? Okay. 80 divided by 6. Okay. So I got a decimal, so let's leave it as an improper fraction because that's more fun. Yeah. 40 over 3. Yeah. You a little key to know if you're going to have a repeating decimal is if you have like 9, 6, or 3 in the denominator, you're probably, if it doesn't divide out evenly, it's going to be some type of repeating decimal. Okay. All right. Number 3. Yeah. 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 I know what decimals are. All right. We're going to have to cube it. Okay. X plus 10 is right there. 4 times 4 times 4. Wow. So are some of y'all that thought that some of this was confusing previously are now understanding the process now? Maybe, kind of, sort of. I know some of y'all don't want to actually admit that you're understanding the math because then you would actually, it's like you're giving in. Like, no, that's like surrendering. I ain't going to do that. It's clear as mud. The transparency mud actually depends on the type of soil used and how much water. You ever seen mud on the white sands of Dover? Okay, y'all can argue about that later. Okay, so number 4, first thing we would need to do, this is my radical. I need to add 8 to both sides first to isolate the radical. And then you would cube it. And then you get 216. Yeah, don't admit it's getting easier because then you're giving in to the ways of the J. Actually, I got to do it this way. The way of the J. The way of the J has a meeting this weekend. All right. Here's our radical. I need to subtract 14 first. Okay. Now I need to divide by -3. Dramatic voice. Intense math. 16x equals 8. Now I get to here. What do I do? You what? You square it. And then we divide by 16. Guess what we get? 4. All right. Number 6. Here's the radical. What do we need to do first? Add 16. Okay, this gives us 30. Okay, now what do we need to do? We divide by 6? Is it like a question? Not really sure. Now what would we do after we've got the radical isolated? Cube it. And then divide by 25. All right. So, even though in the beginning of the lesson it may seem odd that somebody said isolate the radical, raise it to the power of both sides, and then solve, you might not have understood what that meant. But hopefully, after seeing 2 examples and 6 problems worked out, it's a little bit more better. Okay? A bit clearer. It's okay. All right. Extraneous solutions. Okay? Now, I will tell you this. All the problems I've seen that comes with the textbook that I don't give y'all ends up being more work to actually solve the problem than to understand exactly what the problem is. Okay? So, I actually choose a little bit less difficult of the problem to actually get here. Okay. Kind of the thing that we need to notice first is that we have x equal to the square root of something. Okay. That means we're only wanting positive numbers as our answer. Ooh, kind of went print and cursive all at the same time there. All right. So it's kind of like one of those people saying, send in positive vibes. Okay. So the first thing we would need to do is actually square both sides. Which gives us x squared equals 7x minus 10. Now, I need to move everything to one side so it's equals 0, so it's similar to something we've done before. Now, it's written like this because we should know, hopefully by now, that none of these are like terms and they're not going to combine. Okay. Now, if we were to solve this by factoring, this tells us the signs are the same. This tells us they're both negative. Okay. What two numbers, when you multiply them, you get 10, but you add them, you get 7. Okay. Now remember, our answer is the opposite. So it'd be positive 2, positive 5. Are both of these numbers positive? Yes. So we don't have any extraneous solutions. Okay. When we have an extraneous solution, we will actually get one negative and one positive. Okay. And we only want the positive answer. Because we're saying the square root of something cannot be a negative number right here. I know that's very contradicting because when you take the square root, you got to do the positive and negatives. It's, you know, can we get in the Wayback Machine and just go and like try to tell these mathematicians to not do as much opium as they did to make stuff confusing? So, all right. So that one didn't have any. So let's look at this one. Somebody might be thinking these problems look familiar. I wonder where we might have seen these before this week. It was on the test that we had about solving by factoring. It was very funny. All right. So we're going to square both sides. Okay. Now we're going to move everything to one side. I'm going to write it up here just because I want to. All right. We go to factor. This tells us our signs are different. Bloop, bloop. This tells us our bigger number is negative. What two numbers, when we multiply them, we get negative 30, but when we combine them, we get negative 1? Okay. Now, when we solve this, we get negative 5 and positive 6. Now, remember, what do we only want? So 6 is our answer. Okay. All right. Believe it or not, that's the lesson today. Thank you for tuning in. Don't forget, tell your friends, bring them next time. Tell them to hit the bell, hit the like, hit subscribe. It finally feels like fall out here in the great state of Alabama. Hopefully, everybody has a nice weekend. Don't do pumpkin spice thing because apple cider is so much better than pumpkin spice. Yes, good stuff, good things. Roll Tide.